Hi guys, welcome back to the channel. In today's session we will be diving into further Linux commands. Some of these commands you might be already be familiar with, such as ps, kill commands, chown and more. So we will be diving into these soon. So the first command that I will be talking about is the ps command. PS command basically refers to process status. The process status command is utilized for showcasing all the information associated with the active processes which are basically running on your system. There are other commands also, such as top, um, but yeah, unlike top, the process command basically gives you the process status in real time. So it gives you a snapshot of all the processes which are running at the moment. So the basic usage of process status or ps command basically goes something like ps. When you hit enter, you can see that since I'm running Windows systems or Linux, only bash and the currently the ps command that I just executed right now, these are the two commands that are active. So you can see that all the active processes on your shell are depicted. So you can see information associated with this as PID, TTY, time and the CMD itself. CMD, so what are these? So PID simply put refers to the process ID, while TTY basically refers to the terminal where the process is currently running, and CPU time is basically also shown as time, so the amount of time it all was consumed running, when this particular process was running. In this case you can see it was almost instantaneous. And while the CMD basically refers to the command, so there are only two commands which were active. So so that is bash and ps. The another command which can be added on to ps is aux. So when you write ps aux and when you hit enter, you will see all the running processes on your system. So the example output here, you can see the user who's the root, and the process ID, the amount of CPU resources he or she is consuming, and similarly the memory, and same way the process owner, CPU usage, memory usage, the virtual memory being used, physical RAM being consumed, again the terminal where it is being depicted, the stat is the process status, the command itself, and the start and stop time. So yeah, these basically appear as in form of columns. Moreover, if you look at the stat column, you will see something, some SS, SL, all of these texts. So they basically refer to the status, like, or the state of the specific command or the process which is running. So R would be shown as running, so this particular command is right now running, while T would be would also be shown. In this scenario it is not here, so it means that that specific process has been stopped. S basically means it is in sleep or is dormant, and Z would be zombie, or like it has been terminated or but not removed. But yeah, so since in this scenario I am not able to show you the T and the Z symbols, which they are not, those states are not shown because such a state doesn't exist as of the moment. So yeah, you can also filter these processes. So for example, if let's say you want to see any process which requires Python running, so let's say if you type ps aux hyphen grep followed by Python, and when you hit enter, um, oh sorry, let's get a hold of Python. So you can see that it basically goes through this entire list, and you can see all the data associated with the Python command. So like with Python processes which are running and where they are running, and the same thing as before, but you can see the specific information shown, like which of the command. As of now, all of the states associated with the Python associated functions, they are all asleep, or they are dormant. So yeah, you can also use it to, let's try to get hold of all the processes which do not utilize, let's say we are basically excluding um, the Python associated processes. So let's say Python, we basically write the same command as before, but we use -v, which is basically acts as an invert. So it would invert this list, and then we will get something like all the processes which do not have Python. So you can see that um, it has been inverted. So the last line basically would show you grep itself would be added. So yeah, you can also specifically show processes associated with users, so which requires you to display the process. If you have processes which are running, if you have multiple users, some specific user might have run a specific process, you would basically sort it so with the help of PSU and the user. In this case, let's say who are the which are the processes which are running under the belt of root. So you can see that it basically gives you the process ID, the terminal location, and the time consumed by each of these process and the commands which are here. Similarly, you can also show the process hierarchy. So like some processes have other processes running in concurrence, so you would like to see the child parent relationships. So for that, you basically write something like PS processes and facts, and you hit enter. You can see all the same structure. You can see like some of these commands have some other commands which are being initiated, and how the entire structure looks like can be also be visualized. So under that case, you basically use this particular command called PS facts. So it will showcase the parent child relationships. So it can help you identify which are the processes which got started by some other uh, command in action. Moreover, you can also use something called as pgrep. So pgrep basically can be used in order to get process IDs associated with specific softwares which might be running on the system. So when you write pgrep Python, you get the process IDs associated with that specific process. So it could be Firefox, Chrome, and so on and so forth. And so through this process, you basically are able to filter down to that specific OS or software which is in charge. So the next command that we'll be diving into is the top command. The top command is kind of similar to PS, but this is a command which is used for monitoring real-time system performance, such as looking into the CPU usage, the memory usage, the running processes, and other system statistics. So for that, you basically use something called as top. So how to execute this? You basically write top, and when you hit enter, you basically would see something like this in real time. So you will see this entire table of information, it is actively getting updated in real time. So it basically showcases the CPU load, the tasks, and the memory usage associated with these tasks. So it would be shown as system load averages, the number of tasks which are running, sleeping, or as I had shown before, like in process there are 3-4 states. So it could be sleeping, it could be certain processes which have been terminated but not having removed, and some commands which are still running, or they might have been stopped. You can also see the RAM usage as well. So this system tray basically is showing you information such as the PID, which is the process ID, the user who is in charge of running this particular command, then the priority of the process, which is shown in the third column, you can see, and then also nice values. You can see that nice values basically is something like which is utilized in specifying the priority of the task. So in this case, certain tasks might be given a priority. This it goes in hand with the PR column. Then the resident memory, that is this, which is actually the RAM. So you can see that the amount of RAM which is being consumed by each of these specific processes. Then the CPU usage, this is the virtual memory here, so the amount of virtual memory which is being consumed. And this is the CPU usage, the amount of CPU cores or the percent of CPU memory it is consuming. The time plus, you would see something like this, which basically shows that amount of time the CPU has been used, and then the processor name itself has been shown over here at the very last column. So if when you want to exit, you basically press Q and it will quit this entire tray. Another way of looking at the same table is something called by using htop. It is similar to top, but this is highly interactive. This is not, from what I know, is not pre-installed, so you will do something like sudo apt install htop, and when you hit enter, it will basically get it installed or updated. And you hit htop and you hit that, you will see the same structure but in a little bit more colorful manner. It is a little bit more verbose and far more intuitive to look at. So you can see the amount of memory which is being consumed, the number of tasks which are running, the load average, and the amount of time the CPU has been consumed, and the same tray as before, but yeah, a little bit more I guess it's easy on the eye. So you can see that, and you can also filter by each of them as well. It's also an alternative, and again you can quit the same by pressing the Q button, and when you do so, you will exit out of it. Yeah, you can also sort by CPU usage. If you type let me do that again. If you press P, let me see, yeah, when you press P, it will basically sort by the CPU usage. You press M, it will do the same. It will again sort the processes by the amount of memory it is being consumed. Alternatively, if you press M up and down, it will basically, alternate, it will change. And yeah, if you press K, like as you can see, which I will not do right now, the K button, I will not recommend that you would use so, but the K button, when you press it, when you are opening this tray, it would kill specific IDs. You can also filter by specific processes by using the / as well. You can also change the frequency of update by changing it to D equal to some value. Let's say equal to, let's say in 1 second, and when you hit enter, it will change. So let's say, and yeah, now you can quit with the help of Q. I would not suggest you to mess with this too much, but yeah, as a friendly reminder, this is how you would look into different kind of processes which are running on your system. Now the second command that we will be talking about is the kill command. Yeah, the kill command, as of now on my system, it wouldn't be visible that much, but if you have certain processes which are running in real time, let's say, for that you basically use the kill command. In a large system where certain processes are always running, this is highly useful whenever you need to get certain processes to start, stop, restart, or terminate. So you can basically look up all the processes which are running by again typing psaux, and when you go through this list and you find certain commands that are not required anymore, under that scenario you basically use this, let's say, the psaux. Let's again do the psaux and look up all the Python processes which are not required. So let's say we will do that, help, and when you hit enter, you get that specific data associated with it and the PID. um, yeah, and let's say we would like to get rid of this specific PID, and let's to do so you will write something like kill 171 and hit enter. Yeah, that's the main issue. So certain commands would not be, done so as easy as I show, because because some processes are essential, you can force. So but you can do that again by specifying the sig terms. So sig terms are basically used to gracefully stop. Let's say when Linux gives you multiple signals, you can control these specific processes. So for that you use something called as a signal. So if you want to terminate a specific process, let's say gracefully, like gracefully we mean to say that a default stop. So the sig term or the signal term that is used is 15. So you will type something like skill 15. Let's just say, in this case it can be 15, or you can directly write it like -sig stop. Let's say sig stop. Let's type sig stop, and then the ID itself, which could be anything here. And yeah, so there are like 5-6 signals or signal terms associated here. So one is sig term, which is used for gracefully stopping, while sig kill is used for forcefully stopping, and sig up is used for restarting a process, while sig stop is used for pausing a process. Sig up and sig stop, so like if I made any mistake here, sig up would be to restart a process, sig stop would be to pause the process, sig continue would be for resumption of processes associated with that. So each of these have a term number associated with it. So it would be 15 for sig term, 9 for sig kill, 1 for sig up, 19 for sig stop, and 18 for sig continue. So yeah, you will basically write this like in uppercase, like sig stop, then the process ID, then sig continue, which is will be and then the ID itself. And so you would basically stop, resume, or pause these actions. The next command that we'll be diving into is a command called chown. The chown command in Linux allows you to change the ownership of the files or directories. So let's say if you are working in a multi-user system or managing Linux servers, this is important that you would use the chown command. So this command would essentially allow you to change the ownership from one of them to another. So yeah, so if you want to understand what this is, so when you type ls-l and hit enter, you would see the attributes associated with the files and directories which are there at the present working directory, which is in my case it is directory. So you would see all these files and they have their own attributes, and as you can see, these are the privileges for the user, the group, and other users in the network, and these are the links. And while here, this is the important part. So this is the user, this column indicates the users, and this column indicates the group. So in this case, since I am on WSL, it just shows Linux, but when you are working in a large company, you will see large firm or whatever, this data wouldn't be the same, it would be different. In this, for the demonstration purpose, you can see that I just made a group called root and the user. So in this case, the distinction is only being made on the basis of the users, root, and Linux. So yeah, so the ls-l basically is a terminal command, so it allows you to get a good glance at the file ownership. So here the Linux, the first column is basically the owner, while the second column with the same name basically refers to the group. So here bash hello.sh basically has Linux as both the user and the group, and yeah, so we can also change that. So in order to change it, let's say in this case we will change the this owner of bash hello.sh to a different one. So let's say I have created a new user called John, so let's change the ownership to that particular user. To do so, you would type something like sudo chown, the name of the user, and the file. So whenever you perform ownership change, you always need to execute it with the prefix sudo. So sudo is gives you super user privileges, and you are able to execute that kind of a command which basically lets you change the ownership. So when you hit enter, and let's see the, so in this case this user that I have created basically has now access, is the owner of this particular bash hello.sh. So you can see the owner has changed to John, but the group here is the same, which is Linux. So now we will try to change both the owner and the group. Now if you want to change both the owner and the group at the same time, we can basically use this format. As before, we will type sudo chown and then John followed by the group, let's say developers, let's say something like that, and file.txt. When you hit enter, it would say that specific group does not exist. So in order to do so, you will have to create this new group. So for that you will use something like group sudo group add, and let's say developers. You would type something like this, and when you hit enter, this specific group has been created. So now when you try to execute this, should not show you an error, and this specific new group has been created. And when you write yeah, in this case file.txt, yeah, it does exist. So ls-f file.txt, and hit enter, you would see that the owner is John and the group of developers who can get access. So any user who is part of this particularly newly created group will have access to file.txt. Yeah, so let's say groups are basically used to organize and manage user accounts. This basically allows administrators to assign permissions as well as access levels to multiple users simultaneously. The group add command is therefore a powerful tool. So as we just demonstrated here, we basically just created this new group with the help of group add, and then yeah, we can basically create the desired group. And therefore in this case I have just set up the group name as developers. So you can basically change this to, let's say, my group or some other new group that we are making. When you hit enter, it says my group already exists, so like my groups. So now my groups has been created. So yeah, each of these groups also have a unique group ID. By default, system basically assigns the group IDs in a ascending manner. So it's like it just moves from the pre-existing one to the next one, and so forth, so on and so forth. So yeah, we can basically also, when we create this group, we can also user define this specific ID. So we basically can do something like let's say we'll create something like Unix, a new group, and I would like to set the group ID to, let's say, 100 and 1000, something like this. And when you hit enter, that particular group is created. So we can also list out the GIDs by listing all the groups. So for that you would basically write get ent and the group, and when you hit enter, it would basically showcase all the groups that exist. So in this case you can see the different groups that there are. and each of them have their own unique group ID. In this case we just created Unix, so that has a group ID of 110. My developer, my group, my groups, and developers, which is and John. So all of these users and groups have their unique GIDs. Yeah, so similarly we can also go on with the creation of system groups. So they are basically used by, let's say, for special system operations, or you can basically create backups, as well as for performance of system maintenance. So you can basically do that with the help of -r. So let's say we create this specific group sudo, then let's say group, something like this, group add, let's say, and hyphen. So in this case my system, so we are writing something like my system group. And yeah, so this is like a new group which is being created, and when you hit enter, that specific group is being created. So we will write get end group, and then get end group. When you hit enter, you will see that that particular group has been created for the purposes of maintenance. So yeah, so if you have multiple users and you are the administrator and you would like to assign users to this group structure, so you would basically follow up with um, addition of users with the help of a command called user mod. So user mod is a special, another form of special command. So it allows you to basically use these options. So let's say if you want to add, let's say, user John, let's say, so you would like to add him to the let's say my groups. So we would like something like user mod, then -ag, then my groups, in this case my groups, and John, and then you hit enter. You have right now effectively added that special user to that group. So that's how this works. And you can also delete certain groups which are not required. So let's say if you have a group of users who are no longer active on the on a wide area network, or local area network, and you want to get rid of that specific group, you would use something like sudo group del, and then the name, and let's say this my group. So let's say my group is no longer required and you would like to delete it, so you would write group del and then the name of this specific group, and you have now just deleted it. So yeah, so the group add command is effective, which allows you to manage groups in Linux, enhances security systems, as well as simplifies administrative tasks. If you need to create regular groups, system groups, or groups with specific IDs, that's also possible. So that's where group add comes into play. Yeah, so that's it from my side, and let's we'll see you until next time. Bye.